So I'd like to look at some examples of squares and cubes. We're going to be using our lesson 1.4 discovery map, which looks something like this. It's found in the back of your student notes packet, and students will also get an extra copy from me the next time I see them. So again, your students should have this with them. First, I'd like to try to find the square of 1. Students are going to be working first with manipulatives. So if you take a look, we have some squares here, just some construction paper squares. And to show you a square of 1, I'm just going to take one of these. And this is the idea. I can tell by looking at this that the side length is 1. So I could label this side 1. This side is also 1. And when I ask you to find the square of 1, I'm really saying to you, what's its area? Well, hopefully students remember the area formula from elementary school, which is base times height. Or you might say length times width. Okay, so we're going to use this idea of taking the area formula base times height for this 1 or square of 1. So I want to write out this really means 1 squared. And what that would look like in expanded form is 1 times 1. And if I were to simplify that, I would get 1 unit squared, because really you're taking 1 unit times 1 unit. Students are going to be challenged next to find me the square of 2, which really means find its area. If the side length is 2, what would the area be? So I'll grab a few more of my tiles here and see if we can make a square of 2. So I want each side length to be 2 long. These are not perfect squares, so keep in mind there's probably a better model method, but this just happens to be what I made for students because it was quick and seems to work for the idea, if these were perfect squares. Okay. So here I have a side length of 2 units, and a height here of 2 units. So to find the square of 2, I really want to take the base times height. Another way of showing that would be 2 to the second power. What does that mean in expanded form? It means 2 times 2. And if I were to simplify that, I would find out that I get 4 units. And when I take a number times itself, I'm really finding its square, so I'm trying to make a square here. I also could say that that's units squared because we just took units times units. Area will always get us some type of units squared. Students are going to continue this idea next building a square of 3, which really is going to change by making this a 3 by 3 square. And if I were to steal these just so that you could take a peek at kind of the gist of it. A 3 by 3 square, and they could count up, well, how many squares did it take to make it? The answer would be 9 square units, and that's because I'd take 3 times 3, my base times my height, or 3 to the second power, really meaning the same thing. We just simplify it. Okay. Next, we're going to apply that to our discovery map. So here's an example of how this would look. Here I show you what exponential form looks like. It says 1 to the second power, and if I expand that, it says 1 times 1. So the answer is 1 square unit. Here they ask me to sketch it over here. So sketch the square of 1. There, I've done that. To be honest, I'm not sure that it's a good idea for us to keep sketching the exact same ones that they show you. I think it'd be better for us to challenge you a little bit. So in a minute, we're going to also show the square of 5. Okay, so we'll change these in a minute. Square of 6, square of 7, square of 8. Wish I'd caught that before printing all of these for 120 students. Anyway, so next we want to look at exponential form, or another way of thinking of this is what is the area? So here I take base times height, right? And what I don't really like is that maybe this question mark looks like it might be sitting next to the length of the side. It really is talking about how many square units make up this whole entire figure. So exponential form would tell me base times height, or 2 to the second power because it's a square. Well, that looks like 2 times 2 in expanded form. And 2 times 2 gets me 4. And we would call that 4 square units. This is one way of writing it. Another way would be to write 4 units squared with that little exponent of a 2. Take a look at this next one. Here they give me a 3 by 3 square. So I'm actually asking you, what is its area? So in an exponential form, I'm actually taking that 3 to the second power. I'm using it twice, once for a base, once for a height, or once for a length, once for a width. So I would write that out in expanded form. What does that mean? It means 3 times 3. Well, I can simplify that. 3 times 3 definitely gets me 9, and I could call this units squared. Or I could call it 9 square units in word form. This idea continues with a 4 by 4 square. So exponential form would tell me I use that 4 twice with multiplication, meaning I'm going to multiply my base and my height, or my length and my width. So what does that mean to me in expanded form? It means 4 times 4. Remember, we're not showing our multiplication with an x because we're getting ready for algebra. We'll save the x for algebra. So 4 times 4 actually gets me 16, and I think it's quickest to use this format, 16 units square. But again, you could write 16 square units. Well, they've given me this first 4. Next, I could find you the square of 5. So I'm going to sketch in this area here, see if I can show you the square of 5. That means I need to make sure that it's 5 units tall and 5 units wide. So we've gone from what we'd call a concrete model with our little tiny squares that look something like this to something that is a pictorial model. And what I really want to find is its area here. So I want to figure out how many square units it takes. Well, one length is 5, and another length is 5. And I kind of caution students not to label all the way around here, because if you label all of the dimensions, they're more likely to find perimeter by accident. So exponential form, what would it look like? 5 to the second power. What does that mean? Expanded form would say that means 5 times itself, or 5 times 5. Well, if I were to simplify that, my answer would be 25. And again, we'd want to say units squared. When students are working on this, I will encourage them to use color just because it shows up a little bit better with what we're doing. I don't think we should find the square of 2. They already did that for us. I think we should find the square of 6. So to do that, I'm going to do some sketching here. 1, 2, 3, 4, 5, 6. The height has to be 6. But this is a square, so the base has to be 6 also. And I complete that square. And I could shade it in just so that I can really see it. But I might also do this so that you understand that we're trying to find area. I might put a giant question mark on the inside and go, if this side is 6 and this side is 6, how would I find its area? Well, the area really equals 6 squared, meaning base times height. And what that looks like in expanded form is 6 times 6. And if I were to simplify, 6 times 6 we know is 36, and we would call it units squared. There's our answer. I'd ask you to continue the same idea with the square of 7 and the square of 8. And again, you want to make a perfect square when you're drawing these because we're talking about a two-dimensional square where the base and the height are identical. So all sides are the same length. The next thing students could look at is our example conclusion map. So this is next in their notes. It says the topic is the square of a number, and we just practiced that. We did that a couple ways. We did that with this approach, using something concrete. We did that with our notes approach, making something pictorial. So here we call this a pictorial approach. Next we want to kind of move to a rule. So we're kind of moving to the abstract. So it says find the square of 4, and this is what they showed me. 4 squared means 4 times 4, and that equals 16. So 4 squared equals 16. Let's look at another example. Find the area of a square with sides of length 9 units. So that means I'm going to square the number. 9 squared equals 9 times 9. Looks like they got an answer of 81. And in this case, they gave it a label. 9 squared equals 81 units squared. Example 3, square 11. So these are all worded a little differently. Square of 4, find the area of a square, and square 11. Well, it looks like they did the same thing. They wrote 11 to the second power, and this kind of looks like that expanded form that we talked about. 11 times 11. Yeah, 11 times 11 is 121. So here they say 11 squared equals 121. I need to come up with my own conclusion. So what topic are we talking about? To do what? Well, it looks like we're finding the square of a number each time. To find the square of any number. What do I have to do? To find the square of any number, I write the number with a certain exponent, it looks like. It looks like they always use the same exponent. I first write the number, and we might call that a base, to the second power. That means an exponent of 2. And we can tell after making these maps as a math department that we need to kind of expand our room to write. It looks like our conclusions get kind of long. So to find the square of any number, I first write the number or the base to the second power, or the exponent of 2. If you look up here, next, what did they do? What do we call this section right here? Each time. Oh, next, show expanded form. We talked about that in that other sheet. Next, show expanded form of the base. Meaning you show the base twice. Or you could write it that way too. I show the base twice. Looks like we're not very focused here. I'll try to improve that for you for a minute. So next, show the expanded form of the base. And the last step is solve. So let's try our own example. Something that we haven't seen. 4 squared, 9 squared, 11 squared. I don't think we tried 8 squared earlier. 8 squared. That means the square of 8. So each side would be a length of 8. And maybe for fun I'll call this centimeters, because I'm ready to kind of stretch my thinking here. If the base is 8 centimeters, the height is 8 centimeters also. Oh yep, that means base times height, or 8 squared. First, to find its square, I write the number of the base to the second power. The base is 8, I write it to the second power. It says next write it in expanded form. That really means 8 times 8. And the last thing it says is solve. Well, I know 8 times 8 is 64. Now here's the trick. For this one, that was really 8 centimeters and 8 centimeters. And those aren't meant to be exponents, it's just that I forgot to put them in here. So really those should say 8 centimeters times 8 centimeters. When I take centimeters times centimeters, I'm actually squaring the units. I'm going to get centimeters squared. Or we could say 64 square centimeters. Again, whenever you're finding area or the square of a number, you're going to end up with square units. The last thing we're going to look at is cubes, finding a cube of a number. So to do that, we have an example conclusion map. I also have the students make me cubes. So to start with, I have a cube. I want to see a cube of 1 is what I'll tell them. So if you look at this cube of 1, I'd make them think about what this means to me. So I probably would have them work on some separate paper if we had some here. So the cube of 1. I oftentimes will have students try to do a quick sketch for me. I start with a square. That's not very square, is it? And I go ahead and I draw a third dimension, kind of drawing this 7 off to the side and connecting my corners. Well, in this case, I'm not trying to find area anymore. I'm trying to find volume. Well, that really means I don't know how many units it takes to make this. But I do know that it's 1 unit long, 1 unit wide, and 1 unit high. Oh, yep, there's my cube of 1. So what does it mean? Volume really means length times width times height. So I'm going to plug those ideas in. I'm going to say this really equals 1 to the third power. I'm using that 1 for length, width, and height. If I were to stretch that out, that would look like 1 times 1 times 1 in expanded form, and I would get an answer of 1. Now, if I want to label it, I would call it units. But keep in mind, I just took units times units times units. We used that 3 times. That's units to the third power, or units cubed. That's your answer. You just found me the volume of the cube of 1. That's the cube of 1. Next, I'm going to ask them to find me the cube of 2. That means that I want the length, the width, and the height to be 2. So right now, this is pretty close if you look. Looks like I have a 2 by 2. The problem is if I turn it for you, you can see that it's not too tall. So I need to make sure that it's a little bit taller here. So a cube of 2. I want it to be 2 in all dimensions, the length, the width, and the height. Probably would have been better if I had shuffled up the colors here so you could see a little bit better, but we'll call it good. So here I have a cube of 2. How do I know that? Because it is 2 in all directions. And I'm only going to label 3 of these surfaces, or 3 of these edges I should say, because what I'm trying to find for you is its volume, length times width times height. I really only need 3 dimensions to do that. So volume equals length times width times height. Oh yeah, I'm going to use that 2 3 times, or to the third power. Let's see, so to cube 2, that means I write the base 3 times in expanded form and show multiplication in between. Be careful, sixth graders' favorite mistake is to call this 6, 2, 4, 6, but that's not really what's happening here. 2 times 2 is 4, and 4 times 2 is 8. This is 8. And again, we have units, but this is three-dimensional, and we found the volume. That means I have units times units times units. I use those units 3 times in multiplication. Units squared. Sorry, cubed. Units cubed. This idea would continue. We could kind of draw out some others if we wanted to. You could even sketch in kind of the edges and how it would look if you wanted to, so that maybe they could count up the cubes in their figure. And again, this is a pictorial approach. Next we move to the abstract, the rule. So here they say cube 3. They wrote 3 to the 3rd power. For this one they say find the volume of a cube with a side length of 5 units. They wrote 5 to the 3rd power. And this one says find the cube of 2. They wrote 2 to the 3rd power. It looks like each time they stretched out that base, they copied down the base and showed it 1, 2, 3 times. 1, 2, 3 times. They showed the 5 1, 2, 3 times. And the 2 1, 2, 3 times. So if you look, I'm cubing the number, I'm expanding the form of this exponent, and it looks like I used that base 3 times. Well, next it looks like they simplified. 3 times 3 gets you 9. And I have to bring down this times 3 to solve. 9 times 3 gets you 27, and they actually said 3 cubed, or 3 to the 3rd power, is 27. Okay, I can follow this. If you take a look at this next one, 5 times 5 is 25, and you have to bring down this extra times 5 to happen next. 25 times 5, oh yeah, I can see that. And they labeled this one. Why did they call it units cubed? Oh, I had units times units times units. I used them 3 times. I got it. Take a look at this example. 2 cubed, or find the cube of 2, it says. Oh, they still wrote out that 2 3 times because of the exponent. And they simplified. 2 times 2 is 4, and 4 times 2 is 8. I got it. 2 cubed is 8. And that makes sense to me here, because it's really taking 2 times 2 times 2, a length times width times height. Okay, so how do I write a rule? To do what? To cube any number. What did I do? I first write the side length, or maybe we'd call it the base, to the 3rd power. Next, we had to write it in expanded form, right? We expand the expression, or you might expand the base, showing it 3 times. Lastly, we solve, taking the base times the base times the base. And some students will want to kind of push their reasoning and their understanding here. They might even add something about the label or the units, how it will always be units cubed if I'm talking about volume, length times width times height. Try my own example. Well, what's one we haven't looked at? How about the cube of 4? So I'll try first of all to draw a cube. This is a square, so I need to make it 3-dimensional. Here we go. And I know I'm going to use a length, a width, and even a height. Okay, volume equals length times width times height. Just thinking here about a formula I know. Maybe that will help me cube the number. So to cube a number, I want to write this volume will be the same as 4 to the 3rd power. What does that mean in expanded form? It means that we're out of focus again for some reason. It means I'm going to write out 4 times 4 times 4. Most popular wrong answer, 12. But we don't want to fall into that trap. So 4 times 4 is actually 16. And 16 times 4. Well, 4 times 10 is 40. 4 times 6 is 24 more. 40 and 24, I get 64. It looks to me like I'm going to get 64. And if I wanted to label this, I'm not sure what they're measuring in, so I'm just going to call it units. And it can't be units which are a linear length. We have to talk about cubes, because we're talking about how many cubes would form this figure. So we'll say 64 units cubed, or 64 cubed units, or cubic units. Again, this is how we solve squares and cubes. When we think about building up numbers, I sometimes call it math Minecraft. If you're building with squares and cubes, the numbers are going to grow.